Is that even capturing that stuff? Okay. Now I can take derivatives. So what happens? I think this is where you're going.
So it's 1/2.
1/2 comes down.
Cosecant.
Yeah, and watch. Do you notice all the rules? If you are doing more than one derivative at once, you better really know you're allowed to. Because normally with the rule, you do one derivative at a time. I take the derivative of something to the 1/2, so that something stays the same. You don't start putting this guy's derivative in there. They don't get a turn at the same time. I want to ride. No, I want to sit on his shoulders, go around. Ah! No. Should probably give the kids a turn, right? Okay. Oh my God. Now the inside gets a turn. Where'd it go? Yeah, there. Inside check. There you go. And now you can focus your attention on that derivative. A lot of you guys still are trying to do it all in your head, and that's when a few of you don't know when to stop chain rule. Times. It's because you're trying to guess. No, write the rule. Is there going to be another chain rule now? Yes, because I have an inside function that isn't just x, right? I don't know if I want to do that. I've already done it on the answer key. I'll give that to you in a minute. Is that all right? I mean, cosecant is one of the worst. Secant and cosecant suck. Because their derivatives are, and you gotta be, a lot of you guys, all right, this is what scares me. Not to pick on anybody. I don't even remember who did this. But somebody did this. All right, I'm sorry. I didn't say your name. I don't even remember who you are, to be honest. Yeah. You should feel a little bad about that. I'm sorry. You just should. It makes no sense. If you write this somewhere in a problem, that makes no sense. Doesn't make any. It's like writing this. Y is square root. Y is root. Right? That doesn't make any sense. Square root of what? Cosine of what? So here, this derivative, real quick, just do one more step. What's the derivative of cosecant? Negative cosecant of it, not x. Negative cosecant of the angle times cotangent of the angle, and then times, of course, the derivative of the inside. Is this going to involve a chain rule? No. So no guessing. There's no guessing about when chain rule stops if you're being nice to yourself and writing the rule and then doing the derivatives. If you're trying to do all the derivatives at once, you're going to be like, when do I stop? Why do that to yourself? Why try to keep all that in your head at once? It's craziness. Math is hard, yes, especially when you're trying to do the whole problem at once in your head. Oh my God. Let me give you this answer key. This is going to suck a little bit because there's 2 pages to it. Part of this is in red because I started making it. I didn't have a normal pen. Got there? Yeah. Yeah, there's cosine every sign. Yeah, but what I mark wrong is I forget to. Not necessarily, although I am trying to get you guys to get that something on the memory, so you don't have to waste time reading around. Part of me loves you to read around. But part of me doesn't want you to have to do that every time.
Oh yeah.
If that was because I know that the limit of sine x over x is 1. So the limit is sine 3x over 3x. And that's also so if only that this. So can't I do 3x?
No,
Now I put 5 there instead. Put 5 on top of it.
and then you need to.
Yeah. So But the idea of, I want a 5 there, so let me multiply the outside by 5 so I can find this side. This concept. Take the 3 out of the way, replace it with 5 by balancing. Dude, I know, it's like, to me it sounded like saying, man, when you breathe, you think of it. Think about that. I get you guys, don't worry. You know, Liam, you get one eventually. All right, let me see if there's anything weird on here. I managed to fit all of them in there, yeah. 2 on where? Sorry? Quiz 2. I did. Quiz 2, number 2?
Yeah, it's the one that says find the location where the thing that we're
Yes, we did that earlier. Yeah. You just take the derivative, set it equal to 0. That's where you have to factor. And then you have to, we had it up here a minute ago, you have to put your stuff together that's inside. So you get 3 answers, not just 2. Yeah, a lot of people got 2 answers because they didn't go far enough with the factoring. Yes?
Number 20 on 3.6. It's differentiating.
Oh, good. So this is still rewriting perfect. So now you start thinking about it. So what's that? This is h of t? Z. Oh, I like it. So if it was a function of 2 variables, they would have had to say h of a and z. A comma z. So they're saying z is the only variable in that. A is a constant.
So you just differentiate and make it equal to 0.
I love it.
Even though it's squared.
Even though. Just to remind you guys, I know I've said this before, but do not just stare at my answer key and agree with it. I know some of you guys do anyway. You don't get anything out of that. Yeah, I would have done that. Totally, I would have seen that. No. So if you don't do the practice test, don't look at the answer key. It's that simple. Yeah. Oh, yeah. All right. 1G. This is an example of a problem where you have to take natural log. That's the x to the secant x one, right? Yeah. Whatever I said, Al. So you have to take natural log. So we call that other side? You take ln and the secant comes down. Now to be honest, you can't, anyway, you can memorize the way this is going to work, but screw it. Just take an ln because you don't have a rule for a function of x raised to a function of x. You just don't. That's a combination of 2 different rules. So you try to tear them apart. And now we do take natural logs. And now it's just a product of 2 things I know. What's the derivative of this side? 1 over y. Yeah, dy dx equals. And now this is going to be what? What's the rule? Product rule. Derivative of secant is secant x, tangent x, I like it. And of course times natural log x. That's the derivative of secant. Leave that alone. Plus secant, what's the derivative of natural log? I'll let. Now, when you solve for dy dx, you're going to multiply by y, but what is y? This thing. Y is this. So when you multiply by y, you're actually multiplying by this. And I think, I can't remember if I simplified it more on the answer key, but might have. Real quick, number 5, the problem number 36 from the book. I got a little pen happy there, so I kind of rewrote that step there. See where it's natural log of t and it's all crappy looking? Now you can see why when I'm grading your stuff, pencil, because that's annoying as shit, right? So if I got a lot of that on every problem, forget about it. Sometimes on the homework, if I have somebody who just will not use pencil and you turn in homework and you have a lot of stuff scratched out, I say redo this, turn it in late. Thank you very much. Next. Yeah. Number 11. So this one's got big ass f of y. It's y squared, right? It's 3 over y 4. This 5y cubed. Getting old is fun. Can't see shit anymore. Now this is the product quotient rule section, so technically you should attack this with product rule. If you simplify this, I totally understand. So what happened on this? So first thing I would do is make this y negative 2 minus 3y negative 4. Cool. So now it's more the shape of my rule. So when I take the derivative, I'll take the derivative of this guy first, right? Times leave this guy alone, plus leave this guy alone, derivative of the second. So what's the derivative of the first dude? The gas. And then what's the derivative of this guy? So here the derivative is done. Now you should simplify, right? You can see it would be a lot easier to simplify first and then take a derivative. So I can't blame you if you do that. Is that all right? I mean, yeah. So now you would FOIL, get your like terms together. Yeah. Yes. Which one, sorry? 101. Oh, 101. Okay. I was like, what in the world is she asking? 101. This is page 267. 101 was the last dude. Oh, yeah. This one is exciting. What does angle of elevation mean? Elevation. Angle of elevation means what? I'm going to pull whatever that woman's name at the Republican, whatever that. Oh, yeah. Angle of elevation, if you look horizontally, angle of elevation is the angle that you look up to something. It's equal to the angle somebody has to look down from that point to see you, too. I mean, it makes sense. They should both equal each other. So when this says the angle of elevation of the sun, so from a point on the ground, if I look up at the sun, there's the angle of elevation. Elevation. Relation to the horizontal. So if I'm up in a plane and I look down, this would be the angle of depression. Okay. What else does it tell you? So that's decreasing at a rate of 0.25 rad per hour. So d theta dt is 0.25 negative. How fast is a shadow cast by a 400-foot tall building? All right, and this would be the shadow of the building. Are you with me? So as the sun's going down, the shadow is getting longer. I like it. Where do you go? Increasing when the angle of elevation of the sun is pi over 6. So the snapshot is theta is pi over 6. Because that, of course, is changing over time. Okay. What else did they tell me? Anything else? Blah, 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 blah. I like it. So, what's the question asking? In symbols. Well, there's a symbol I have to put up on here. Where's the shadow again? I like it. Where is the shadow? This guy. So let's call that X. I like that's an awesome idea. So in symbols, what's the question asking? What is dx dt? Is that yes? So to be really honest, as I drew this, I forgot doing this. I was like, wait, I'm missing something, and then I realized, okay, what's the question asking about the shadow? I got to give that a variable then. Because that's what's changing as the sun goes down. This is getting longer, like we said earlier, therefore that's where the other variable comes from. So as you go through this, you should be able to piece it together. Now, do you guys see how I collect what they tell me, I collect what they're asking me in symbols, and then I step back and say, what's the equation that relates everything? So what equation can I set up here? I have to be related to the angle, right? Yeah, okay, tangent theta equals. So x equals 400 over tangent theta. Or otherwise x equals 400 times, who's it? That, what is that? What's the reciprocal of tangent? Cotangent. So then you take derivatives. You see how d theta dt is going to come popping out. You're going to have still a theta piece, so that's why they tell you pi over 6. They tell you what d theta dt is. You're going to have dx dt. It's awesome. It's already solved for it. But that's the steps. Draw a picture if it's helpful. Write down what they tell you. Write down what they ask you. Make sure you have it represented on your picture or in your equation. Then you step back, to make the equation, you say, how does everything relate? That they've told me stuff about, and they ask me stuff about, how do they all relate? Sometimes it's very simple, because they're like, the volume, I'm going to use the volume formula that day. It's amazing. But sometimes it's like this thing, they don't say anything about tangent. You're the one that has to see that that's tangent. Or cotangent, if you want to start there. Why not sine?
Because we don't have a variant for the hypotenuse.
I don't care about this. You could actually get an expression for it. Square root of 400 squared plus x squared. Holy shit. I don't want to do derivatives of that thing. So let me pick a trig function that's better then. That involves only the things that I know and am asked about. I like it. If they would have said, how quickly is the distance from the tip of the building to the tip of its shadow changing, I would have called this R or something, right? I wouldn't care about this side then. Then I would have used sine. Okay, I don't know what you find. It's just because I'm curious about this side. That's why I end up using tangent. If I was curious about this side, I would have used sine. Y over R. Okay, maybe. And in this situation, I do not want to see decimals. Because pi over 6 is an angle you know everything about. Even if you don't, I say you do. You have to. You're here. And you know I'm going to give you at least one problem where you have to do trig of angles. Anything else you guys want to look at?
We'll look at 35.
3-9? Oh yeah. Oh boy. All right. So the minute hand of a clock. They're assuming, I think, let's see where to go. I think they're assuming the length from the center. Length R. So that one's a little evil because it goes past the center. But we're talking about a clock that just starts this. Find the rate at which it sweeps out area as a function of R. I love it. So if you wait a little bit, it's going to sweep out a certain area. This kicks so much ass. So if this is theta, what's the area of that? Like, what's the name of that pi piece? All right, let's take a trip down memory lane. What's the arc length? How long is this? It's only equal to theta if R is 1. Do you guys know what a radian is? Why do we call radian a radian? Why do we give it that name? What the hell is a radian?
It's the length of the corresponding circumference of the circle.
Yeah, so if I have a certain angle and I measure it in radians, if I have 1 radian, that means I took a radius and I bent it. It's the distance a radius goes, right? So this is 1 radian. Why can I use it as an angle measure? If my circle gets bigger, the radius still fits in that area because it got bigger. Also, equivalently bigger. Radians make more sense for angles because they're actually physical, real measurements. Degrees are shit we made up. Now, if you want to get down to it, we made every damn thing up about math. But everything else has got to be coherent. Degrees, why is it 360? Because 360 divides into a lot of ways. That's the only. It could have been 480 degrees in a circle. It could have been 2 degrees in a circle if we were really going crazy. All right, sorry. I don't know if you guys realize that. 360, there's nothing special about 360 except it's easily divisible by a lot of numbers. Yes?
My last year's math teacher in high school, she told me they said it was 360 because similar like how Earth goes around the sun.
Yeah. So you got the Babylonians have a base 60 number system because then they could represent their number system mimicked the year roughly. So yeah, exactly. So that there is a kind of a reason. And to be honest, it's a little bit that, and it's easy factorable over a lot of different numbers. Okay. So the arc length then depends on how long the radius is. So the arc length is r times theta. Is that Sound familiar to anybody?
Sounds familiar.
So let me cut this pie piece out and put it here. Here's the pie piece, right? How long is this?
That's Oxford.
Doesn't that look built like a triangle?
Kinda.
Just has a curvy bottom?
Yeah.
If I made it really thin, wouldn't it have basically a flat bottom? Isn't that the idea of local linearity? If you zoom in on something, it's going to become flat, like the surface of the earth looks flat, and we know it ain't. Is not. How tall is this triangle? Triangle. Yes. So what's the area of the triangle? 1/2 the base times the height. The area is 1/2 r squared theta. That is the actual equation. It's an awesome way to remember it. That isn't quite why. It's just useful that coincidentally it works out like that. Just a little bit of both. That is the area of a sector of a circle. So that's the formula you're dealing with. And we're dealing with clock, right? So it's how fast is that hand, is that moving? And I think we're talking about the minute hand, right? Not the second hand. So the minute hand, where'd he go? Minute hand. All right, I was looking at the second hand. So the minute hand takes how long to get all the way around the circle?
60 minutes.
All right, so takes an hour, right? And they don't say anything about, no, okay, I like it. So it goes, how many radians is that it goes? How many radians does it go? Yeah, 2 pi radians per hour. And that is what? Maybe something related to this function we're working with. What is r in that equation?
Radius.
And it is constant, right? The only thing that's changing is theta. And this is d theta dt, isn't it? I've done enough for them. You just take, oh yes.
So why do you justify truncating the circle to the area equation?
Truncating this, or how do you mean?
Because if you're taking like 1/2.
All right, now let me just say this. Let me restate what I said earlier. This isn't the proof. This is a beautiful way to remember this equation.
Oh.
We're lucky that it looks like it worked out the way it did. And to be honest, that itself isn't quite true. You just don't know enough math to get to the point where you can see this is true. Not yet. This comes back in later calculus courses. And you actually get to see exactly why this is true, especially Calc 3. But it's so beautiful that it actually acts this way. It has to do with limits. And, I mean, that's why I said if you made a very small thing, this is straight. It really is. But that is just a very beautiful way to remember that this is how it works. Now, to be honest, you could actually prove this by realizing that you know the area of the whole circle. So if you wanted the area of 1/4 of the circle, what would you do? I mean, so you could just do proportions. Yeah, that's more direct proof of why that's true. Okay. So I didn't go through the proof of that. I went through a way to remember it. That's a formula you should know. So you take derivatives of this. R is a constant. So what is the derivative of this going to be? I'll do this side. I'm done. You guys done? Careful. What's the variable in this thing? Theta. Is R changing? That would be a really funky-ass clock. Tick, tock, tick. The arm is staying the same length, isn't it? This is a constant, so it's 1/2 r squared d theta dt. You know what d theta dt is? I love this problem because you had to stop and think about an actual clock, and think about the rate of how the thing is moving. It's kind of nifty. If you know anything about Kepler's laws, it's kind of relates to area swept out. Yeah. If you don't, it's okay. You don't have to.
It'd be funky though if you have an ellipse there. Or it'd be
Yep.
funky and do the same thing because you have an ellipse.
Yes. Ellipses make a lot of things more funky. That's why I like them. Yes.
Page 181, number 64.
Oh, beautiful. All right. I don't think anybody's asked me about this question, have they? Maybe somebody. I can't remember now. Yeah, I don't think anybody's asked me this semester about this question. And when nobody asks me about certain questions, I freak out because I'm like, well, they're just skipping it or they're not doing the homework or something. And I know at least you're not turning it into me. I don't know what this shit's going on. But find equations of both lines through the point 2, negative 3. So we got the point 2, negative 3. Lines through that are tangent to this. Now, just to illustrate what I said earlier, a rough sketch of this is a remarkably good idea. So, can anybody tell me anything about this? Parabola, I love it. Let's get that out of the way. Now tell me something more interesting. The x-intercepts are 0 and 0 and negative 1.
And also 1? No. No.
The vertex would be at so it'd be at negative 1 half, negative 1 half, comma, whatever the shit that is. So it's right here, somewhere right there, right? That's got to be a rough sketch for me. Opening up. Where's the point that I'm dealing with? 2, negative 3. So the point I'm dealing with is right there. So somewhere, if you keep going here, somewhere there's going to be a tangent to the parabola that goes through that point. And of course over here, there's going to be a tangent to the parabola that goes through that point. There, find both lines. Oh shit, that's why it makes sense. It's sort of like that ellipse where I said, where does it have a slope of 1? Well, it was here and there. They both had a slope of 1. It's the same idea. So here's why they say find both. So I bet you anything in the working of this, I'm going to get some kind of quadratic. It's got two answers. So how the shit do I work this thing out? Tangent to this. That tells me to...
So you get 2x plus minus 1 tangent line.
Yes. So y prime is?
2x plus 1.
Okay, so there's one thing. And that is the what?
That
The slope of that curve everywhere. The slope of the tangent line at every point. And now the next step is what's really interesting. So what is this answer? What is that answer right there? Tell me the answer.
looks like 1 half.
Oh, you don't know. So what is that? X, Y. No, it's not. What is it? X, comma, what? What's Y? If I'm going to be on this parabola, I better be working in that damn equation, right? So what point is that? That's one of the answers. What point is that? The point x, x squared plus x. That is also this point too, isn't it? Because it's the general point on this curve. That is another way to define this curve. It's the set of all points where this is true. It goes through every point like this. Now, what is my line supposed to go through?
It's supposed to go through
This point and
that point.
2, -3, right? And what was this again? This represents the slope. Oh, shit. So if I get a slope, it better equal that. How do I get a slope between these 2 points? y2 minus y. Yeah, okay. So I would do x squared plus x minus 3, plus 3, sorry. y2 minus y1 over x2 minus x1. So what is that? That is the what? That is the slope of the
Bottom.
tangent lines. What's this? Slope of the tangent lines. So this better
Equal that.
equal that. Oh, I love that problem. Oh my God, I love that problem so much. You would, Jeff. You would. Don't study the shit out of this problem. Make sense out of why I did what I did. That's the more important thing. I'm not going to give you this problem. I'm going to give you a problem that is sort of like this one. So I love it when a student comes up to me and they say, we never did a problem like this. I'm like, yeah, you're right. But it's got all the concepts we talked about. Oh, that makes you feel really uneasy. I know it does. Too damn bad. This is where you got to really understand the idea so you can apply it in any situation that it requires. Yeah.
So you have a point inside of the parabola.
Ah, so that's part B. The way to make this not work is to put it inside. Then there is no tangent line to the curve that goes through the point because all my tangent lines are kind of external, aren't they? So that's part B, is to realize when you do the math, you're going to end up with something that has no real answers. But on the picture, you can see it's not going to have any answers, right? If you draw the picture out for yourself. Yes?
So, okay. Like for proof, like on that problem, I drew a sketch and said like only one line could pass through like that point and, you know, the curve.
Well, I realized I had to think about it more. I wrote, no, there's a lot of them, but I'm curious about the slope. If you had a, so you said this one, and that's not a tangent line, so it's not even the question really. But if you move it this way a little bit, how far can it move before it's going to eventually hit this other guy? The rate of increase here versus the constant rate of increase there. Do you see what I'm saying? That's its own little interesting problem that I didn't have time to look at, but it's curious. It's interesting. Notice though that they say, show that there is none. Where'd it go? Show that there's no line, and the second part says draw a diagram. So a diagram by itself is not good enough. You do actually have to go through the same kind of work we did here, but this is going to lead to no real answers. Whereas this one leads to 2 real answers. I like it. Now if I had a point on the parabola, how many answers would I get? 1. Because there's one tangent line that goes through the point on the parabola. Yeah, that's kind of a silly question. All right, so the lesson from test 1 should have been really do the homework. Do it. Do all of it, as much of it as you can, and make sure that it's you doing it. I get the feeling that for some of us that lesson wasn't really learned. So you're going to just experience the same thing again, possibly on test 2, that you shouldn't now because you should have been doing homework. I think there's at least one person in here that's been doing the homework more than they were before, and I'm curious how this test is going to come out for them. Some of you guys are doing great. Some of you guys are fine. You're doing the homework honestly. You're not getting everything right, which is not the way it's supposed to be. You're not supposed to come in knowing this shit yet. If you did, hey, great. Enjoy it while you can. But some of you guys are just... I love it, especially when a student turns in work and only the odd ones are done or something. Like, oh, okay. I used to joke about answers will vary. You ever seen answers will vary? I used to joke somebody, and now that was like 12 years ago, the last time I joked, because then it just started happening all over. Answers will vary. What do you mean? What do I mean? Oh, God. Put a little effort into your cheating. Or don't cheat. I don't know. One of those two. So remember, I have office hours right before class. I'm in there before 6:30. If you come in and knock on the door, I'll either come over to you and say, I can't open up yet, or I'll open up and let you in. So you might as well knock if you're here. Huh? When's the class start? 7. So if you're already taking a 7 o'clock class, 6:30 isn't too crazy. Some guys are like, yeah, but I roll in about 7:20 normally. I don't know. Fine. And you chose poorly. Of course, I also have office hours 9:45 to 11 today. If you want to come by, there's tutors. We all know everything that's there. Has anybody found like good online videos stuff? Anybody even look for any? Besides, the ones I put up. Khan Academy is always the first place to go. MIT has all of its courses up online. You can go see an MIT professor teach Calc 1 without paying MIT tuition. Yeah. So it's okay. If you guys don't have questions, you can leave. It's okay. If you have questions, I'm here. I didn't bring anything. Yes, you can turn it in after Thursday, but then it's late. The later it is, the less total points you could get back. If you get enough right, you will always get points back, but it's less and less and less. Yeah.
For sure.
Right there. Yeah. Sorry, man. I should. Oh, there's one right there. Yes.
Oh, you're right.